Like the coordinates, I get.
Woo. Okay. The distribution of car color in Oro Valley is the same. I basically just sort of cheated off all the words in the question. So it says, do the data provide convincing evidence that the distribution of car color in Oro Valley differs from North America? So I said, okay, let's just assume that it's the same. And then let's test to see if it's different. Okay, so I'm gonna pretend to be Bryce for a second. He's gonna put his hand up and say, "Mr. Talbot." Oh, nice. Thanks for playing along. He's gonna say, "Mr. Talbot, can I just do like that quotation-y thing underneath? Because it's all almost exactly the same sentence, except for the same different." And I'll say, yes, not on your test, but on your homework, by all means, do the quote. You know what I'm talking about?
Yeah.
Like when you write the same thing underneath, it's like, you put a little quote. Oh, but I'm just saying, yeah,
Yeah, no.
I was just
The
going,
skipping stuff.
yeah.
Yeah.
So we really did not, I just made that up.
I know.
But I'm just saying, the homework is your place to do that, not the test. The test is when you write it out. Okay, all right. Now, it did not give us an alpha, so we're going with 0.05 because it's moderate. Any questions so far? Is this what you would have expected from what we learned yesterday? Okay, great. Plan. Chi-squared test of goodness of fit. It is not a chi test. It's not a chi test. Yeah. Chi-squared. Okay. Random. Indeed. Random. 10%. Okay. So then you pause and you go, what was her sample of? Yep, cars in Oro Valley, Arizona. Do you think there's more than 3,000 cars there? I don't either. You were just there. Well, not probably in Oro Valley. I don't actually know where Oro Valley is. I don't know anything about it. I do know that some of our like family friends are moving to Prescott, Arizona because the housing prices are much cheaper. But it costs like 5 times as much for fire insurance there for some reason. Because apparently they get these like fiery winds, windy fires, fire with wind in it, like a wind storm fire thing. Okay, anyway, all right, so large counts. This is the only bit that's new so far. Okay, and before we can answer that, we have to go up here and do some maths. Okay, now the large counts condition is met if all expected counts are greater than or equal to 5. But I gave you some space for us to calculate those. Okay, so what you're supposed to do is we're gonna show our work in this box, and then we're gonna put the answer in this bowl. Were you saying you taped over it? Was that what the uh-oh? All right, well, 6 and 2% of 300. So anyway, okay. So this box would be 300 times 0.23. Okay, do you guys see where I got 300 and 0.23 from? Okay, so let's all just work in our groups to fill in the rest of this table. So you can definitely break up the work and talk about it. I just did that on calculator. Guys, calculator. I need to hear more tapping of the calculator. And then if you did it correctly, those should all add up to 300. Okay, now I made this example of, and they all come out really nice whole numbers. That is not necessarily the case all the time. Sometimes the expected counts are decimal, and that's okay because it's a mathematical model. So we're not expecting those to be perfect. If you get a decimal for if you get a decimal for an expected count, please write the actual decimal. Okay? Those do not have to be whole numbers. Got it? This one came out pretty, but they don't always. Okay, so anyway, does it meet the conditions? So are they all greater than or equal to 5? Yeah. I love her. Miss Schlotman in the office. She was my student back in the day. Okay. Now we're to the do part. This is the part that I really wanted to focus on today. And so we're going to do most of this in the calculator, but I want to make sure you have the base, the minimum of what College Board will want to get full credit. So what I want you to do, we're going to make a little box over here in our notes. This is going to be calculator instructions. So make yourself a little side box there. You're just looking as I've ever written, but it's fine. Okay, so this is your little calculator cheat sheet. Pretend it's a little Post-it stuck on the side of your note. And then grab your calculator. GOF. It's like fog and goff. No, it's not. Do you guys know what fog and goff is? Calculus people? Compositions of functions, f of g, g of f, fog and goff. Okay, it stands for chi-squared goodness of fit test. But I like to say it like goff. Okay, anyway, so scroll up to your data here and go to your calculator. And for me, I'm going to clear out my lists. So if you go to second plus sign, you might not have played with the calculator before, but if you go second to plus sign and then number 4, it will clear out all of the lists so you can start fresh. And then go to the list is stat, enter. Oh, and they'll be all clean. Okay, so now we're going to enter the observed, which is the Oro Valley list into L1. 84, 38, 31. Don't put the total in. You'll throw off the whole thing. Okay, then put your expected into L2. Okay, then, yep, that test. Okay, so this is the moment in time where you're going to be mad at me. All of the due things for all of the test and intervals are located in the calculator. Okay, why don't I teach you this? Because College Board requires you to show your work, then the formulas, and label all of your stuff. And if you just got something out of the calculator, it would not be full credit. So I don't teach it based off the calculator. If you're someone who loves a calculator, by all means, go back in. But even with this one that we're gonna do off of this, I'm still gonna have you show some work because I want you to get full credit. So scroll down to D. D is chi-squared goodness of fit test. That test, scroll down to D. And notice real quick before we move on that chi-squared test is here. And so that's the one we're going to learn for the rest of the chapters, that one. But we're doing chi-squared goodness of fit test specifically right now. Okay, it's going to ask you some questions. It's going to say, is your observed in L1? Yes. Is your expected in L2? Yes. What are the degrees of freedom in this problem? 7. And then go to calculate. Okay. Now, we need all of this information. We're going to use it all. But what you need to know is, what do I need to show the College Board to get full credit? College Board is going to require you to do part of the chi-square test. Okay, so this is what you write. You write chi-square equals. Okay, and then you take your first number, observed minus expected squared over expected. What? Kind of, but we're not going to have to show the whole thing. 38 minus 54 squared. Okay, then after you write the first two, put plus dot 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 plus This is still full credit with the College Board. You just have to show the first two and the last one. So that is 39 minus 21. Okay, and then you come back to your chi-square statistic in your calculator. So I'm going to round mine to 29.92. Notice the calculator did the p-value also for you. So it ran chi-square CDF. That doesn't mean that I don't have to write that. I still have to put what I did. And this one is scientific notation. Don't be scared. (9.82) times 10 to the negative 5. Indeed. We got a tiny number. So real quick, just to make sure you understand, because of the graph, the way the graph is shaped, you will never have a negative chi-square. Also because you're squaring all the numbers and adding them together. So it's always this to infinity every time. There's no negative infinity to worry about or anything like that. Any questions about what we did so far? Okay, does anyone notice that there's something else on our calculator that we didn't use yet? Okay, so there's one more thing we need to do this period. Yeah. I probably have enough room. I don't know why I didn't. You have plenty of room. What? You can probably fit it. What was up with the what? Let me, you guys can look at my calculator. Okay. Fine. Oh. Okay, so I think I might have screwed you guys up because if you cleared all your lists and you might have accidentally cleared your lists again on accident, I don't know. Okay, but anyway, okay, last thing we need to do is the follow-up analysis. It sounds bad. I promise you it's not. So first, there's a couple of things. We only do a follow-up on analysis if we reject Ho. So it's only worth doing if we reject the Ho or it says statistically significant, which is what rejecting Ho is. Rejecting Ho and statistically significant are the same thing. Okay. And what you're going to do is you're going to look for 2 or 3 biggest contributors to chi-square. What that means is, when you have all those fractions that you add up, observed minus expected squared over expected, which one of those is the biggest? Which category had the biggest contributor? And your calculator did that for you also. Did you notice? Okay, so on your calculator, it's called CNTRB, which stands for contributors. Okay, so it's right here. So if you scroll over, you can get all of the individual chi-square terms. Do you guys see what I'm saying? Okay, so let me go back to the beginning and make sure that we understand what this is doing. This is just so cool. Did you see how fast it did it too? Sorry, I just geek out about stuff. Anyway, okay, so these are the white cars here, which is 3.26, which means that if I did 84 minus 69 squared over 69, that would be 3.26. So this first number is this piece. And the second number is this piece. Does that make sense? Okay, and it did them all separately for you. Okay, so now you need to find the biggest 2. So everybody look on your calculator, find the biggest 2 categories. So the third one is 6 something. And the last one was the other. Okay, so it's gray and other, right? You guys all see what I saw there for getting gray and other. Okay, so then what you do is you just write sentences comparing these to their expected. For example, we're going to write a sentence about gray. There were fewer gray cars than expected in Oro Valley. Okay, and 31 versus 48. Do those numbers make sense? 31 and 48.
Yeah.
It'd really make a lot more sense to me if I had kept this on the same page. But no, I flipped the page over. The giant page. Okay, now we're going to do the other category. There were more other okay. And that's it. Oh, excellent question. Look back at the table and compare the observed and expected. So for gray, you observed 31, but you expected 48. So that means you observed less than you expected. And then for other, you observed 39 and you expected 21. So you observed more than you expected. It just means you saw more than you thought you were going to see. Oh, yes. What a pain that I have that on 2 pages. Did you guys fit it on a page? I think I could have fit it on my page too. I don't know why I did that. The biggest things that made it reject the hoe. So gray were really off from what they thought, and other was really off from what they thought. And those were the biggest things that contributed to making the chi-square so big so that we rejected the hoe. Big, because it's like that number to infinity.